Hi viewers, welcome to my channel. Today we are going to see about programmable logic devices. So this concept comes under digital logic design subject. So it is very important concept for designing any kind of logic circuit. So programmable logic device is nothing but it is an integrated circuit. Simply we can say ICs. So which a combination of a lot of internal logic gates that are connected through a electronic fuses. So each and every programming of the PLD can be involved with the help of blowing of internal fuses to achieve the desired logic function. For example, if you want to design half adder or full adder, etc. So for that, in combinational circuit, we are following different method to design a logic circuit. The same combinational circuit can be designed with the help of PLD in different way. That is, the logic symbols are different somewhat compared to normal combination circuit design. So the blowing of internal fuses are mainly connected in this PLDs, which is used to achieve the desired logic function. And all PLDs are consist of different programmable arrays. Programmable arrays are grid of conductors. That means different rows and columns are connected together with the help of fusible link at each cross point. So simply we can say matrix are formed here. So that is the concept of rows and columns are connected with fusible link in each cross point. So arrays can be either in the form of fixed array or programmable array. That means fixed array means the designing part is simply as it is fixed, but programmable means each and every combination of SOP functions or POS functions like that, the functions can be programmed in different way. So the gates are PLDs divided into three category. That means simply AND array or simply OR array are connected together both AND OR implementation. So that is PLD's classification. So the gates in PLD are divided into three. AND array, OR array are connected together to provide both AND and OR implementation. So for this, first we go for programmable OR array. So the OR array consists of OR gates connected to a programmable matrix with fusible links at each cross point of a rows and column. So that should be connected together. So array can be programmed by blowing each fuses to eliminate the selected variables from the output function. So with the help of this logic diagram, we can differentiate how the programmable array is programmed or unprogrammed. So here we set a programmable OR array. So we have to take only OR gates. So OR gates are connected here and unprogrammed OR array. So that means we take two variables A and B. These two variables are inverted also. So A bar, B bar. So these four variables are now act as a input. So now I just connect all the different variables together with the cross point of rows and columns. Here the different rows are connected in horizontal lines and columns are connected in vertical lines. So this particular symbol is called as a fusible link in programmable logic device. So now the Y1, Y2, Y3 are the three outputs which produced from the each and every OR gate output. So this is the circuit for unprogrammed array. Now we move to programmed OR array. So in this case, the same variables A and B are also taken and the corresponding A will be inverted. So A bar and the B variable is inverted. So B bar. So now we can give the expression that is what is our desired output Y1 which is equal to A plus B. So if I want to design this particular logic that is A plus B. So for that I have to fusible, that is the connection between the A line and the A bar line, the cross connection between this particular rows and columns that is established with the help of this fusible link. So Now the variable which is connected here is called as A. Similarly, for in between of B and B bar, the fusible link is connected in this cross point of this particular row and column matrix. So the corresponding variable which is called as B. So the y1 which is equal to A plus B. Similarly, y2 equal to A bar plus B bar. So in this case, the fusible link is connected in between of A bar and this B. So the connection made in between of this cross point, that is the A bar line and this particular line rope, automatically the corresponding variable is denoted as A bar. Similarly, in this case, the fusible link is connected with this column line B bar with the row line. So we can say the A bar and B bar are connected together with the help of this OR gate. So y2 is equal to A bar plus B bar. Similarly, for A plus B bar, A is connected with the help of this fusible link and B bar also connected with the help of this fusible link. So final output or desired function is y3 equal to A plus B bar. So this is the programmed OR array concept. The same manner we can design programmable AND array. So instead of OR array, here we are using only AND array. The same variable also taken A bar, B bar, as it is what we have seen in unprogrammed OR array. The same diagram cross matrix is formed here also. Instead of OR gate, I just put a AND gate here, and output also assigned as y1, y2, y3. So in programmed AND array, the same concept, instead of OR array, here we take AND gate. So what happened? A into B. So y1 which is equal to A into B. So the A is connected with this fusible link and B also connected with this fusible link. So A into B is the output of y1. And y2 which is equal to A bar into B bar. So A bar which is connected with this fusible link and also the B bar is connected with this fusible link. So A bar into B bar is the second output. Similarly, for third output is y3 equal to A into B bar. So this is the different kind of AND arrays and OR arrays are connected with the help of fusible links at each cross point of the row and column. So this is blowing fuses. In this form, we are going to design the PLDs. So what are the different classification of PLDs are available in recent days? So it is mainly classified into three categories. First is simple programmable logic device and a complex programmable logic device, field programmable gate array. So in this programmable row, programmable logic array, programmable array logic, generic array logic, 4 category comes under simple programmable logic devices. So this is main program. Programming PLDs. So next we just differentiate how the AND array and OR array are programmed in various devices. So in first column we assign devices PROM, PLA and PAL. Second column AND array, third column OR array. So for PROM, AND array is fixed, OR array is programmable. So simply we can say programmable read-only memory is a fixed AND array and programmable OR array logic device. Simply next we go for PLA, programmable logic array, which is consists of programmable AND array, programmable OR array. That means both AND and OR arrays are programmed together. So which is called as a PLA or programmable logic array. So third category of devices PAL, programmable array logic. In this AND array is programmable and OR array is fixed. So now we can see the array logic symbol. So normal the conventional symbol for particular expression, how the same can be presented in the form of array logic symbol for PLD devices. So A, B, C, D, these are the 4 inputs which are connected in this AND gate. It will produce the output Y variable. Simply we can say Y is equal to A into B into C into D. So here, for example, here only 3 fusible links are connected. So in D input, there is no fusible link, that is it is in open condition. So at that time what happened? The Y which is equal to A into B into C only. So for D, there is no input connected with this AND gate. So the D will not be the output of the particular AND gate. So this is conventional symbol. The same can be represented in the form of different ways with the help of fuse blown, fuse intact condition. So which is called as a array logic symbol. So whenever you go for PLDs, that is a programmable logic array or programmable array logic, at the time we have to follow this simple symbols for assigning the particular operation. So here we take A, B, C, D as it is, what we have taken here, and the single line is connected to the AND gate, and output Y is the AND gate of output variable. And now in this case, three fusible links are connected together. The same fusible link is connected here. Instead of the symbol, here we have to put a cross, that is simply X mark. So which is called as a fuse intact. That is, the connection is established with A, B and C. So simply single line is connected in D, which says the no connection, that is fuses in blown condition. So this is array logic symbol for the conventional symbol. So next, normally we use inverter symbol, that is one single diamond symbol, so triangle symbol, and with this bubble is there. So here we just give A or B, C, etc. Any variable can be given. So the directly A is taken here, and the bubble output will be A bar. But the conventional diagram, this A inverter is represented like this, but the same array logic symbol is represented in different way. The triangle symbol is taken here, and first side of or top side of triangle is taken as a variable, and the bubble is represented below, and now the connection is taken from here, so which is called as a bar. And third concept is A, B, C. These three are connected in AND gate, and with a single line we can put a dot and A, B, C. So the output will be A into B into C. So these are all different array logic symbol for the equivalent conventional symbol. So let us see programmable logic array with examples. So programmable logic array, already I told you, it is a combination of programmable AND array and also programmable OR array. So PLA is mainly used in logic design where number of don't cares conditions are excessive. At the time, this particular circuit more economical. So whenever you have a more number of don't care condition, to reduce that, and complexity of the circuit is very high. So to overcome this problem, we mainly go for this PLA. So in PLA, the decoder simply can take ROM. So it is replaced by the group of AND gates, and each of which can be programmed to generate a product term of the any input variables. So AND and OR gates inside this PLA are initially fabricated with the help of fuses among each of the OR and AND gates, and specific Boolean functions are implemented in SOP form by blowing appropriate fuses and leaving the desired connection. So now let us see the example for PLA. So simple example. So implement the following function using PLA. So in this case, the Boolean function, that is the output function F1 is taken here, and F2 also there, F3 also there. In this summation M 1, 2, 3, 4 is there. So from this we understood min term represents SOP function. That is, the three Boolean functions are represented in the form of min terms. Because of summation and small m is represented here in the output of F1, F2 and F3, and the corresponding min term values are 1, 2, 4, 6. Here 0, 1, 6, 7, and for last case 2 and 6. So from this given question, we have to draw the truth table. So first truth table, this is the step 1 for designing the PLA. So A, B, C are three inputs. So in this case, we understood 1, 2, 4, 6, 0, 1, 6, 7 and 2, 6. So out of this min terms, the maximum min term value is 7 here. So from this we can understand there are 3 input variables which is present in this example. So for this simply we can say ABC. ABC are 3 input. The possible combination of 3 inputs are 0, 0, 0, 0, 0, 1, 0, 1, 0 till 111. So this is possible combination of inputs when we have a 3 input variables. And we have to find the output F1, F2 and F3. So for that we just put a F1, F2, F3 are the separate column. And in F1, 1 is a min term, 2 is also min term, 4 and 6 also min term. So for this case, we just put a 1 and remaining terms will be assigned as a 0. So 1, 2, 4, 6 are min term. So in this min term, 1 represent 0, 0, 1. So for this case here, the output F1 is assigned as a logic 1. And here 2, 0, 1, 0. For this logic 1 is assigned here. Next 4, 1, 0, 0. So for this case assigned 1. Again 6, 1, 1, 0. Here we assigned 1. For similarly, if we go for F2, 0, 1, 6, 7 are the 4 min terms. So first 000 are the 3 inputs. The corresponding min term output function F2 is equal to 1. And 1, 0, 0, 1 is assigned as 1. Again 6, the 1, 1, 0. Now the value is equal to 1. And 7 is also 1 min term. The corresponding output will be 1. So the remaining terms, so 4 terms are assigned as a 0. And for last case F3, only 2 and 6 are 2 min terms which present in this output. So the 0, 1, 0 is the 2. The corresponding output assigned as a logic 1. And for 6 also assigned as a logic 1. Similarly, remaining all 6 min terms are assigned as a 0. So this is a truth table. So from this the ABC are the 3 input variables. F1, F2, F3 are the output variables. So next we move to K-map simplification, because if we want to draw the logic diagram, we need to find the expression. So for that we proceed with K-map simplification. So K-map for F1, because we have 3 outputs, F1, F2 and F3. So for F1, we have to draw the K-map. So what are the different one outputs are present in the function of the table F1. So at that place we just put a 1. Remaining min term should be assigned as a 0. So why here I put empty column means whenever we see it, we can't find which is taken as a output. So for that case, whenever I explain, I just put as a empty column. After explanation, I just include this 0 for remaining columns. So here the one variable are taken here, and we have to map it. So whether octet mapping combination is possible or not, we have to check. So here the octet mapping is not possible because 8 ones are not available here. So and quad mapping is possible or not also checked here. So here also it is not possible. So dual mapping can be mapped here. So we just take these two particular column values which is connected together, that is mapped. At the same time, this is the corner mapping, dual corner mapping also there, and single mapping here. So for this we can write the expression. So for the single particular column dual mapping, B C bar is the expression. For this case, A bar B bar C is the expression, and the corner mapping A C bar is the expression. So the F1 is equal to A C bar plus A bar B bar C plus B C bar. Similarly, for F2, we can draw the K-map and we can write the expression. So wherever we have a 1 in the truth table, at that place we can put a 1. Remaining places are assigned as a 0. And we have to map only 1 for SOP. So I just map this 1. So it is a dual map. It is also dual map. So for this case, the expression is A bar B bar. For this case, expression is AB. So F2 equal to A bar B bar plus AB. So similarly for F3, the K map is only two variable is, the two mean terms are present. So for that, we just take this particular min term values 1, remaining will be 0. So this corresponding dual mapping expression is B C bar. So this is F3 equation. So from this we can able to draw the PLA circuit. So here this is a PLA program table. So you just remove it. It is not a PAL. So it is PLA. So PLA program table. So initially we have to take a product term. So what are the different product terms which present in this F1, F2, F3? These all are arranged in this first column. That is product term. After that inputs A, B, C and output F1, F2, F3. So the first term A bar, B bar, C which is present in this F1 expression. So that is taken here. The corresponding input variables are assigned as A bar which is for SOP is 0, B bar 0, C is 1. So the corresponding output F1 is equal to 1. And for next case A C bar which is present in this F1 function and A C bar. So A is assigned as 1 and C min term or literal. B variable or literal is not present in this expression. So we just put a hyphen and C bar is represented as 0 and this term present in this F1 output function. So here we put a 1. And for third, B C bar is a one of the min term which is present in this F1. So which is written here B C bar. Here the A literal is missing. So we just put a hyphen and B is assigned as 1 and C bar assigned as a 0. This is output for F1. So put F1 here. Remaining three terms are considered as a hyphen, that is dash. But this the B into C bar which is present in F1 and also F3. So for here B C bar the F1 output is equal to 1 and F3 output also equal to 1. F2 assigned as a dash. And for say next case A bar B bar A B. These two are the variables which present in this F2 output. So for this case A bar B bar, so 0 0 and C is not there. So put a hyphen and only this term is present in F2. So put F1 variable is 1, remaining will be hyphen. And A into B also represented as 1 1 and C literal is missing here. So put dash and F1 is dash, F3 also dash, F2 is our output. Next we can draw the logic diagram for PLA. So here the A, B, C, three input variables are assigned here and the inverter is connected like this because this is the array logic symbol. So the top line represent A and the bottom bubble line represented as a bar. So here the variable A, the top line is assigned as A and the bottom line A bar. Similarly for variable B, the top line B and the bubbled line are B bar. Similarly for variable C, top line is C and the bubbled line is C bar. Now we have to draw the logic. So F1 which is equal to A into C bar. So for this case A into C bar. So here the A line is crossed, that is fused here and the C bar is fused here. Similarly A bar B bar C is one term. So for A bar and B bar and C. So these three are fused here and which is connected with AND gate. Here also it is connected with AND gate. So say for next case B C bar. So B is connected with this fuse and C bar also connected with this fuse. So AND gate output is B C bar. And the next case A bar B bar. This is the output of F2. A bar is fused here, B bar also fused here and it is connected to AND gate. Next A into B. So here A is fused and also B is fused. So it is connected with AND gate. So this is the output. So till this particular area, which is called as the programmable AND array. So this particular area is called as a programmable AND array, because with the help of this AND gates, we are programmed with the fusible links, which is arranged in the form of rows and columns with the help of available input variables. So this particular area is called as a programmable array logic or programmable array AND array area. Programmable AND array or programmable AND logic. So now this is move to the next step. That is, we have to add this all AND function. So finally we will get a R function that is equal to F1. So F1 is equal to A bar B bar C plus A into C bar plus B into C bar. Now what happened? The single line is connected with this OR gate, and which is fusible with the help of this cross lines, which is the output of F1. So F1 is equal to, already we found the expression A C bar plus A bar B bar C plus B C bar. The entire three term of expressions are fused here with the help of this row and column lines. Finally, we get a F1. Similarly, for F2, A bar, B bar and AB, that AND gate output is fusible here, and which produce the output F2. So, equal to A bar into B plus A into B. Next, F3 is single B C bar. So only single line is connected, and which is fusible with this fusible link. Finally, we get a F3 output. So this is the output for F1, F2 and F3 function. Now we can say this particular area is called as a programmable OR array. That means with the help of OR gate or OR logic, we are programming with the help of this fusible link. So this concept is the programmable OR array. So already in starting of this programmable logic array PLA, I already told you which consists of both programmable AND array and programmable OR array. So programmable AND array is the combination of different fusible functions with the help of AND gates, and programmable OR array consists of combination of OR gates with fusible links. So this is called as a programmable AND array and programmable OR array combination. So this is example for programmable logic array PLA. So I hope everyone understand this concept clearly. So if you have any doubt, you can give some comments. Surely I will clarify it. Thank you all. Subscribe my channel.